Alright, today's lesson is called Chain Rule. I've called it your new best friend. This is the rule that you can use over and over to break complicated equations down into small pieces so that you can differentiate each piece individually. The rule is simply this. Given an equation that can be rewritten as a composition function, I'll give you an example in a second, you take the derivative of the outside function and then multiply that by the derivative of the inside function. So for instance, I've given you x squared plus 1 squared. The outside function there, the f of x, could be written as something squared, where, change my pen color here, that's what we're talking about as being f of x. Is something squared right there. And then g of x could be written as the inner function, which is x squared plus 1. So if we were to take the derivative of something squared, we should remember, using our power rule, that the 2 comes in front, and the 2 then goes to a 1. Okay? What goes into parens? Well, what goes into parens is what was already there in the first place, the g of x. So you just write him in there just the way he originally was. So you've now taken the derivative of the outer function. Now for the inner function, the g of x. We know from our past experiences that given a function like x squared plus 1, all that happens is the 2 comes in front, giving us a 2x, and the 1 goes to 0, so it is gone. So we can just put a multiplication sign right there, and we are done. We have just differentiated x squared plus 1 rather, squared. You could distribute and combine like terms. At this point, I'm more interested in seeing the pieces broken out than I am in the distribution and combining of like terms. So let's continue. Let's look down at our second example. We have the square root of cosine of x. Again, the trick in this is to begin to see functions as composite functions. I could rewrite this as f of x being, can you see it? The square root sign. And g of x being the inner function of cosine of x. Now, we've been working with differentiating square roots before. So f of x would simply be negative 1/2 of this thing right here. So we can just write it this way. The differential of f of x would be something to the negative 1/2 power. What's something? What goes in these parentheses? The original g of x function, which was what? Which was cosine of x. Now, the g of x, the cosine of x, we know that when we differentiate cosine, we get negative sine. So that's going to be a negative sine of x right there. And the rule simply says we multiply those two together, and we are done. The derivative of the square root of cosine of x is cosine of x to the negative 1/2 power times a negative sine x. Again, we could simplify that down further and put cosine on the bottom, but at this point I'm interested in seeing the pieces more than I am in seeing the reduction. Okay. Now, as we're doing this, we need to begin to see composition of trig functions as well. And these are not as easy to see without a little bit of practice. So let's take a look at sine of 2x. What that's really saying is that h of x that h of x is equal to the sine of 2x. It's important you understand that because now you can see that sine is a composition function, that h of x is a composition function. Can you see the outer function? The outer function is sine of something. The inner function is the 2x. Okay, what's the derivative of sine? Well, the derivative of sine is cosine. Cosine of what? Cosine of the original contents, the 2x. Nothing changes there. And then g of x is 2x. How do we take the derivative of 2x? Well, that's simply going to be a 2. And so the derivative of the sine of 2x is the cosine of 2x times 2. Finally, as we look at our last example right here, this one's a bit of a doozy. You need to recognize a couple of things. First, you need to recognize that this means what I'm talking about is actually the sine of 4x cubed. And we've already said that we need to recognize that the sine of 4x is really the sine of 4x written that way. So now look at this. How many composite functions can you find here? If we think about this, we've actually got 3 of them. The first one being f of x is something cubed. G of x is the sine function. And then we'll call it, I don't know, t of x is the inner function of 4x. Now we're going to take every one of these and take the derivative of them. The sine of something cubed is, think about it, 3 comes down, and the 3 goes to a 2. 3 comes down, and 3 goes to a 2. So it is 3 times something squared. What's the something? Well, the something is all of the stuff that was already in there. So the sine of 4x. Next step, g of x. Well, g of x is the sine of something. So we're going to multiply by g of x. We want the derivative of g of x. What's the derivative of sine? The derivative of sine is cosine of something. What's the something? The something is whatever was already in that, which was the 4x. Oops. And lastly, we want the derivative of t of x. What was t of x? T of x is 4x, and the derivative of 4x is 4. And we are done. That is our final answer. That is the derivative of sine cubed of 4x. This is the work we're going to finish in class tomorrow. I would recommend you spend a few minutes working on some of these problems to try to get the easy ones out of the way so you build those skills, and then tomorrow we can focus on the hard problems.